We're almost there.
Good morning, everyone. I'm so excited to be here and meet all of you. First of all, I would like to specifically thanks to my doctor friend, Professor Li Feng, who is just coming here, who introduced and invited me to these conferences and give a talk to all of you. So I can have the chance to exchange my knowledge and experiences in industry with you guys. And also I can learn some knowledge and ideas from different areas, especially from the academic areas. So today I'm going to go through the topic of AI-powered payments. Briefly introduce myself. I'm currently staff machine learning scientist from Visa Research, and I got my PhD degree in operations research and statistics from Rensselaer Polytechnic Institutes. So a lot of my friends around me keep asking me such kind of questions. What does actually Visa do? And what does Visa Research do? And how Visa Research can benefit or can help Visa's business? Well, in order to answer those questions, in today's talk, I will go through those answers to let you better understand what Visa it is. So first, I will go through Visa's business and explain how its payments ecosystem works. And next, I will talk about Visa's core business, VisaNet, and how we enhance VisaNet through the cutting-edge technology like AI, like deep learning. And after that, I will introduce one of our highlighted products, Smarter VisaNet, and as a kind of case study. Last but not least, I will show you some outlook of our future products by applying like some more advanced technology like generative AI and large language model. So first, let's read some basic statistics about Visa's business. According to our statistics, since last September, Visa has issued around 4.3 billion cards, and with about 283 billion annual payment transactions, Visa has already included around 14.5K financial institutions and around more than 130 million merchant locations in its network. And within its networks, Visa has basic 4 parties in its network. And these 4 parties form the basic payment ecosystem about Visa. Those 4 parties include issuer, acquire, merchant, and cardholder. So for the issuers, which is very straightforward, they are the financial institutions who issued Visa branded card or Visa branded payment products to the consumers. And acquire are also financial institutions, but they are more focused on enroll each merchant in the Visa payment system. And also they process those payments and make sure the merchants can get the paid from their transactions. And for the merchants, any businesses which accepts the Visa payments through their point of sales and online transactions. And the cardholders are any businesses or individuals who use the Visa payment products to make purchases. And I believe that almost all of you are cardholders. So, you have basic idea of the 4-party models, but how those 4-party models process or operates. One is the back engine behind it? Well, the answer is VisaNet. So VisaNet is a global network at the heart of Visa, connecting technology, infrastructure, and innovation to make sure the digital payments are more secure and faster. So let's read some numbers again. Regarding the speed, VisaNet processes almost 775 million transactions a day. And regarding the scale, like I mentioned, VisaNet can connect like 4.3 billion accounts with more than 130 million merchants across 200 different countries and territories. VisaNet can be tracked back since like as early as the 1970s. So during the years, VisaNet has progressed and becomes more and more powerful than before, especially during the most recent 5 years with enhancement of AI technology and deep learning technology. VisaNet becomes much smarter than before. So that is what we call smarter VisaNet right now. So the goal of the smarter VisaNet is to develop next generation network product capabilities and to deliver the smarter authorization, clearing, and settlement for all the 4 parties in our ecosystems. Since 2019, our Visa research has started to build a series of smarter VisaNet products. So here, Smarter Speed is one of our most highlighted products. And Smarter Speed is the first deep learning products in production in the whole Visa company. And the successful launch of these products have attracted a lot of attention and also has got a lot of high visibility in the entire payments industry. So what exactly the Smarter Speed is? First of all, let me introduce or explain a little bit about what STEEP it is. STEEP stands for steady process. It occurs when an issuer is experiencing an outage and cannot respond. So as a card holder, I believe that all of you have the transactional payment experiences. When you make a transaction, when you swipe a card, you definitely will get approval or decline decision immediately or in the real time. But who make this kind of decision? Well, usually your issuer bank, like Chase or like Bank of America, make such kind of decision for you. However, they are not always available to make such kind of decision. Sometimes they have some issues, like network issue, like outage of the power. So during that time, they are not able to make the real-time decision. So in that case, Visa will jump in to make decision for the issuers. So that situation is called STEEP. Well, such kind of situation is not very often to see. It's real, but cause a lot of bad impacts. It has the bad impacts on each 4 parties of our ecosystems. That is because that during this outage time, we have we need to jump in, and previously we make the decision for the issuers based on our static rules. And such kind of rules are usually very, very conservative. So it will cause a lot of declines. So from the cardholder's perspective, you are definitely unsatisfied or have a bad user experiences because you got declined, even though that your transactions is very normal. And from the perspective of banks and merchants, they are also very unhappy, right? Because you lost revenues because of those declined transactions. So that is why we introduced Smarter Speed, which incorporates AI technology to smartly make decision and mimic the issuer's decision for them. So why that smarter Steve are so smart? Here is the technology behind it. Basically, to mimic or simulate issues response, we built some AI model to incorporate and interpret these three basic important elements. The first is account information from our users. The second is the issuer's historical decision logic. And third is the fraud risk information. So basically, we build a model to interpret this, and that's the issuer's decisions prediction. Regarding the model, maybe you are a little familiar with that because I think the last speaker just made a good explanation about this structure. So we choose recurrent neural network with LSTM cells as the basic model structure. As you know, that the RNN model is widely and commonly used in NLP area because it has a good ability to interpret the language sequential model or sequential data. Regarding the LSTM, it is designed for keep the long-term memory to avoid the issue of the vanishing gradients. So the reason that why we want to choose this model structure is, first of all, from model's performance perspective, we have the transaction data is as our input of the model. And the transaction data has a nature of sequence, it has a sequential nature. So we basically use the model to treat each individual transaction as a word, while we treat the sequence of the transactions as for a particular pen or particular accounts as a kind of sentences. So in that case, the model can better interpret our sequential transaction data. Another reason that we choose this LSTM structure is it is good enough and also simple enough for us to implement it into our productions. So that is very important in industrial works because, as you know, we also tried a lot of more fancy like language model, like transformer, like the IM model with attention, and all of them maybe has a little bit left in the performance, but it's not easy to implement in the real world production. So that's also a big consideration in our industrial work. So we don't need a very fancy model, very complicated methodology, but we really need an efficient model which has a good has a balance of good performance and also the easy to implement. Okay, so as I mentioned, the input of our model is the sequential transaction data, and we transform it into the features, and also which goes through our feature engineering pipeline, and then we make it goes through the embedding layers of our deep learning to get a better representation. So with such kind of better representation, it goes through our final LSTM model and got the final output, which is the prediction of the issue's decision. Okay, so how it performed in the real world cases. Actually, we did some simulations on the real world examples. However, unfortunately, I could not, because of the confidential reason, I could not show more like detailed information about the name of the clients or the statistics of the details performance, something like that. But here is a case study I can generally talk about. Back in about 2019, in one day, one of our big clients, issue bank, has encountered a couple of hours of outage. During those couple of hours, it impacts as large as hundreds of thousands of transactions. And also the huge drops was observed in the approval rates. So by applying our models, we observed like big improvements in the approval rates by over 60%. That accounts for increased millions of approval dollar amounts. And also we found, based on our analysis, those approved transactions are mostly at a very low level, a low risk level, which means that those approved transaction is not like a fraud or something like that, which raise the concerns of the business. So besides the improved approval rates, we also have a very good like stable performances based on our out of time validations. We got like a large as over 0.8 F1 score, which is really high in our industry standards. And also during the 6 months testing data, the performance keeps really stable. And also we found that the model has good self-adjustment by inserting and including some more data sets. So because we observed the approval rate between the model and the issues, the ground truths are getting more and more close. And also we, like I mentioned, we do care about the fraud, and the low fraud rate was also observed in the approval transactions. So that is basically how our model and the products looks like. But recently, so our model starts to launch back in 2020. And during the year, we have hundreds of the clients sign up to us, which is a really big excitement and really cheerful. However, during the time and as the number of the clients goes up, we do come across a lot of different challenges as well, specifically in the recent years. One of our biggest challenges for that is we got a lot of requests from our clients asking for a better interpretation of our model decision. So as you know that black box models are always hard or difficult to interpret, and deep learning model is one of them, definitely. So how to do that? Previously, we just our data scientists or the business analyst just manually do the analysis on the root cause. So when the number of the clients goes up, that is really time consuming and less efficient and take a lot of resource. So how to save the resource? So that is how we come to this model explainability, which we call the XDeep, the explainable steep models. So basically, we designed those kind of workflow to combine the existing methodology, which is commonly used in the industry world, like line, sharp, and time sharp. And also we have the patterns, our perturbation methodology. So we combine the results from those different methodology and generate a final models or final explanations to explain our steep models. So in that case, it will become the methodology of the whole workflow will become more robustness and more automatic and also objective because it combines different methodology. So in the era of the large language model, generative AI, and the ChatGPT, we definitely want to incorporate those more advanced technology into our future work of the Visa products. So for example, in this case, we want to enhance our XD based on by incorporating the GPT API and generate or design a more smart or user-friendly interface to have some chatbots with our clients and give more human readable or generate more human readable informations or explanations to them. And also we have some like other ideas like by incorporating the reinforcement learning with human feedback to better enhance our our products, smart city products. So that is all for my presentation today. Any questions?
Also at the end there, I thought you were talking about the explainable AI bit. You're using like things like Shapley values to look into how the models are using various features.
Yes.
But that would be an automated way of doing that.
Oh, yeah, sure. Yeah, so basically the generation, like the output of this methodology are mostly the feature importance.
Yeah.
To investigate which features will be the most important one. But that is not enough. So you can use like random forest or whatever the other methodology to generate feature importance. But this one is specifically some model of cosmetic. So it's not like you can apply that in everyone deep learning, not only the training. So trying to use this methodology to interpret the black box.
So in terms of challenges of utilizing AI for your work, what do you see as the biggest roadblock? And maybe a relevant question. Obviously, you have access to lots of data and variety quality. Any data quality challenges?
Yes, of course. So that is a good question. Like I mentioned, the interpretation is only one of the challenges. We also come across data challenges as well, especially during, as I mentioned, the product was launched in 2019, 2020. At that time, we just have the start of the pandemic. So during the pandemic, the data distribution and the feature distribution has a lot of shifts during the time. So we do observe the model has degraded the performance during those times. So what we deal with that problem is we refresh the model like during the time, and we also have incorporated some new features to better interpret or to better do the predictions more related to our functions. So that is how we do.
And how long, let's say, obviously you don't have to respond to that, but how long normally does it take for a black box supervised model to adjust to data shifts and work properly?
That's a good question, because in the real production, we do, because the model we use contain the states. So we need to, in real production, we kind of use our space to save such kind of states. So it takes our us like 21 days to warm up the whole model's data and to prepare those states. So when we do the validation, we usually wait for those kind of periods, and so to make sure that our offline model is consistent with the production model.
Thank you.
Yeah, regarding kind of the integrations of generative AI, what's kind of the way that you guys are handling hallucinations? I know that pops up a lot with the various generative AI models.
So you mean that how do we deal with the production?
So in production, I know that you've had a slide where you were integrating like OpenAI, API, chatbots.
Yeah.
I know that the OpenAI chatbots and interactions, unless you do certain things to them, if user is interacting with it, it can produce results that are very wrong compared to what it's actually looking at in the data. Basically, I'm talking about what are kind of the guardrails you guys are implementing for thoughts you have.
Question. So recently ChatGPT, as you know, is not public, but like the Llama or something is public. And our team also have some group of person who investigates those public codes. But definitely to make those public codes more suitable to us is we also need to add the like information from our own data sets to enhance the capability of the large language model and do the fine tuning based on the large language model. So that's how we make things happen.
In terms of the market share, because you showed some interesting trend about how data is dominating worldwide. You compared your main competitor, the Mastercard. Do you see similar trends?
I haven't read too much about the Mastercard. I'm so loyal to my. Definitely, Visa has biggest market share in United States. Probably different market share in the other region like Europe or something like that, because different company have different policy strategy. But in United States, Visa definitely take the biggest cake.
Alright, so I have a question about the false positive rate comparing to the current models like machine learning, which what we're doing now, compared to the traditional models. For example, discretized justification, that's what we used to use. But do you see reducing the false positive or increasing them?
So definitely, we use the F1 score as our main metrics to evaluate the models. We do have some baseline model like random forest or something like that. And the deep learning model based on our observation definitely beats those baseline models in terms of the performances like F1 score. And definitely our goal here is to improve our approval rates. So if you improve your approval rate, that may cause that false negative. So we here approve as our negative here, but it's within our band. So definitely because we have a high F1 score, which indicates good false like low false positive, both low false positive and both low negative, false negative. So the model just behave really good in terms of
It's like an overall wrong issue.
yeah, and also beats the other baseline model.
Can we compare to discretized logistics?
Logistics,
Yeah.
that is much more simple even than the random forest. So
Yeah.
random forest is our baseline.
Your best.
Yeah. Last one?
Yeah, if it's a good question.
I believe so. Don't be pressured.
You mentioned an embedding process between like speech engineering and LSTM steps.
Yes.
Can you talk a little bit about that, what that looks like? Is that textual data, numerical as well, or a combination?
Yeah, sure. So embedding is commonly used in the language model. So like the word embedding, it's pretty much similar, like the word embedding stuff. So you have the different dimension. You just transfer your like transaction data set. As I mentioned, that the reason that we use this IM model is we treat the transaction data as a kind of language, right? The particular transaction is like a word, and while the whole transaction history is like a sentence. So we kind of make the embedding and transfer the text or the transaction raw data set into different dimensions. Basically, this is what will be transferred into the embedding layers, which is use numerical like vectors to represent those transaction data. Just like what you did for word embedding to interpret or better representation of your language data. So that's how it works.
Thank you.